Hello friends. Today in this lecture we will discuss the differentiation of Laplace transform. So if f of t satisfies the existence conditions. What are the existence conditions? So first is it must be piecewise continuous. Next is it must satisfy the growth restriction. What is the growth restriction? That is mod of f of t less than equal to m into e to the power kt. So in the previous lecture already we have discussed it, and if f of t, your function, satisfies the existence conditions, then derivative of f of s, that means the differentiation of Laplace transform of f of t or f dash s, this is the derivative with respect to s, will be what? Minus Laplace of tft. Or if you take inverse on both sides, then what we will get? Laplace inverse of f dash s will be minus tft. Okay, so Laplace inverse of f dash s is equal to minus tft. So you can remember this. We have to use this formula in solving different problems. Okay, so how we'll get this formula? Like this, from the definition we have what? From the definition, Laplace of tft. Okay, so from the definition, Laplace of f means your f of s will be what? f of s is your integration from 0 to infinity e to the power minus st into f of t dt. Is not it? This is the formula from the definition of Laplace transform. Already we know that. And to find the differentiation f dash s, that means we have to differentiate with respect to s, not with respect to t, so with respect to s. So under the integral sign, if you differentiate with respect to s, what we will get? 0 to infinity and e to the power minus st into minus t, and this is your f of t. Take it as constant. It's a constant because we have to differentiate with respect to s. So, and take this minus t, because in now in place of f of t it is tft, and e to the power minus st is there. So this integral can be written as minus is there, so minus Laplace of tft, right? So therefore we can find this formula in this way. So f dash s is minus Laplace of tft, or if you take its inverse, Laplace inverse of f dash s is equal to minus tft. Clear? Similarly, the integration of transform, here is the differentiation of transform and this is the integration of transform, and same condition here. If f of t satisfies the existence condition, this previous existence condition, if satisfies means your function satisfies the existence condition, then Laplace of f of t by t, here tft, and it is f of t by t, it will be integration of s to infinity f of s tilde ds tilde. Because we have a limit s, so we change the variable s to s tilde, and in place of s tilde you can take any x, y, any variable, and limit will be s to infinity. So if you integrate this, then the value will be Laplace of f of t by t according to this. So therefore, again, if you take Laplace inverse on both sides, then you will get like this: Laplace inverse of 0 to infinity f of s tilde ds tilde is equal to f of t by t. Okay, so one thing remember, that same thing you will get. You can use this formula, and you can also use this formula according to your question. Okay, so let's do some examples. Right, see here, Laplace of t sin t. So what is this? So how to get it? How to find this from solution? Laplace of TFT. So if you compare with the formula Laplace of TFT, t into f of t. So in place of f of t, sin t is here. In place of f of t, sin t is here. Right. So you can put this formula. What will be this? Minus is here, so you can multiply here minus. So minus derivative of, and remember this is derivative with respect to s only. So minus d by ds Laplace of, means f of s means what? F of s is what? F of s is Laplace of f of t. Okay, f of s is what? F of s is Laplace of f of t. So therefore, minus d by ds of f dash s. So f dash s mane, sorry, d by ds of f of s. F of s mane, what is f of s? F of s is Laplace of f of t. Okay, f of s means Laplace of f of t. So Laplace of f of t means we take it, means your f of t here we compare with sin t. So Laplace of sin t. Okay, so minus d by ds of Laplace of sin t, from the formula we know that 1 by s square plus 1, and that is equal to minus, and u by v formula, from the derivative formula directly you can get minus 2s by s square plus 1 whole square, and if you take minus minus plus, so it will be 2s by s square plus 1 whole square. So this is the result. Laplace transform of t sin t is equal to 2s by s square plus 1 whole square. Clear? Now, if in the next example, if your in place of t it is t square, so what happened? What will happen? Laplace of t square into sin t. Now you can say this t square can be written as t into t. T square, in place of t square you can write t into t. So t into t sin t. Now t, and if you take this formula, take this formula and compare t into f of t. So t into f of t, in place of f of t it is what? T sin t. In place of f of t it is t sin t. So already we know that what is the Laplace of t sin t? 2s by s square plus 1 whole square. So according to this formula, directly you can take minus d by ds of Laplace of t sin t. You can write this as what? Minus d by ds of what? Laplace of t sin t. Minus d by ds of Laplace of t sin t, and already we got it. Laplace of t sin t is 2s by s square plus 1 whole square. So minus d by ds of this is 2s by s square plus 1 whole square, right? So directly just use your u by v derivative formula, division formula, and get your answer. Okay, so what is to be noted here? So in place of t, when it is t, we have to differentiate one time, only d by ds. When it is t square, we have to differentiate two times, because it is one of the derivative of sin t, means Laplace of sin t. Again we have to differentiate with respect to s. So in place of t square, we have to differentiate two times. When it is t only, it is only one time. So we can reduce a formula that if make it a note that if Laplace of, we have to find Laplace of t to the power n into f of t when t to the power n is there. When t to the power n is there, then what will be the general formula? That we have to differentiate nth times. We have to differentiate n times. So nth derivative of Laplace of f of t, and here it is minus 1 to the power n, minus 1 to the power n. Okay, because in the first derivative it is minus 1 minus, then in the double derivative again 1 minus, so minus minus will be plus. So this will be minus 1 to the power n, and nth derivative of Laplace of f of t. Right? So you can use this as a general formula, and if the power of t is n, then we have to differentiate n times. If suppose it is 3, we have to find the third derivative of f of s or Laplace of f of t. So likewise you can solve this type of problems. Clear? So in the next example, we will solve some inverse problem, that is Laplace inverse. What is Laplace inverse of ln s plus a by s plus b, ln s plus a by s plus b? So what is this Laplace inverse? So how to solve it? So in the means using your previous means in just formula, that what Laplace of tft is equal to minus f dash s. We know that Laplace of tft equal to minus f dash s. So here consider this as f of s. This is our f of s. What is our n? This is our f of s in form of s, and we have to find f of t. Means we have to find the original function, and this is the transform function. Transform function is given, and we have to find the original function by taking its inverse. This is our objective. So using this formula, this is our original function if you take, and this is our f of s is our transform function. So we have to take f dash s. So that means what? D by ds of your transform function, what it is given in the question. So therefore, if you use this formula, t into f of t is your minus Laplace inverse of L. Laplace of s is there, Laplace of t of t is there. So if you take Laplace inverse on both sides, it will be t f t equal to Laplace inverse of, minus is there also, minus Laplace inverse of derivative of f dash s, derivative with respect to s. So d by ds of ln s plus a by s plus b, right? Now minus Laplace inverse of, find its derivative. So ln f of x means ln s plus a by s plus b. So it is 1 by s plus a by s plus b. 1 by s plus a by s plus b means s plus b by s plus a into again derivative of s plus a by s plus b. So using the division formula of derivative, what we will get? S plus b into derivative of s plus a minus s plus a into derivative of s plus b. So what will be this? B minus a divided by, and your square of denominator, so s plus b whole square. Now if you check here, s plus b, 1 s plus b is in the numerator, and s plus b whole square in the denominator, so you can cancel 1 s plus b. So it is b minus a divided by s plus a into 1 s plus b is there, right? B minus a by s plus a into s plus b. Now this term can be written as 1 by s plus a minus 1 by s plus b. Is not it? If you subtract it, then it will be what? LCM is s plus a into s plus b, and it will be s plus b minus s plus a. So s cancel, b minus a will be there. So therefore we can write this term as 1 by s plus a minus 1 by s plus b. So now from the linearity principle of Laplace inverse, we know that we can separately find the Laplace inverse of 1 by s plus a minus Laplace inverse of 1 by s plus b. So minus is there in the outside of the bracket, and the Laplace inverse of 1 by s plus a is 1 by a means e to the power minus 80, minus this Laplace inverse is 1 by a e to the power minus bt. So if we multiply minus, then it will be e to the power minus bt minus e to the power minus 80. Now what we got? TFT. This TFT is equal to this. And what is our m to find? What is our m? To find original function f of t. So therefore f of t equal to, just divide t on both sides. So f of t will be e to the power minus bt minus e to the power minus 80 divided by t. So this is your answer. Okay, so in this way you can solve this problem. Similarly, another problem is there, Laplace inverse of ln 1 plus omega square by s square. So same process we can use, take it Laplace of tft equal to minus f dash s, we know that from the formula. So tft equal to minus Laplace inverse of d by ds ln 1 plus omega square by s square. So minus Laplace inverse, that is equal to minus Laplace inverse, and again take its derivative. So this is what? 1 plus omega square by s square means 1 plus omega square by s square means what? S square plus omega square by s square. So 1 by this means 1 by a square plus omega square by a square. Right. So therefore, into again derivative of this, again derivative of a square plus omega square. So using the division formula, so a square into derivative of a square plus omega square, again my a square plus omega square into derivative of t, which means your denominator divided by square of denominator. So a square into 2s minus a square plus omega square into again derivative of 2 square means 2s. So it is s fourth. Now it will be, if you 2s cube and here 2s cube cancel, so only remaining part is minus 2s omega square, minus 2s omega square. So here minus 2s omega square. So you can cancel here a square and s fourth, means only a square is remaining, and again s cancel. So remaining part is what? Only s. So s is there. So 2 into and minus, here it is minus, here it is minus. So minus plus. So omega square 2 into omega square divided by s into square plus omega square. Okay, now I have to find Laplace inverse of this term. Is not it? So Laplace inverse of 2 omega square by s into s square plus omega square. So therefore, if you write this term as 2 by s minus 2 by s, so is it equal to this? Just verify. And using partial fraction, you can write like this: s into, means your LCM is s into s square plus omega square. So then 2 into s square plus omega square minus 2s square. So 2s square cancel, only 2 omega square will be there. So right. So is it okay? Okay. So therefore, Laplace inverse of 2 by s minus 2s by this, means for this term we can write like this. So now only to find Laplace inverse of this term, and separately we can find, because it is minus, and using linearity principle of Laplace inverse we can find Laplace inverse of 2 by s, again Laplace inverse of this term. Laplace inverse of 2 by s means 2 only, 2, and minus this is 2 into s by s square plus omega square, s by s square plus omega square. So what, whose Laplace transform is this? It is cos omega t. So therefore 2 minus 2 into cos omega t. Clear? Now what is this? TFT. TFT is equal to 2 minus 2 cos omega t. We got. But what is our objective? What is our aim? To find out f of t. So f of t will be how to find? Just divide t on both sides. So f of t is equal to 2 into 2 is common here. So 2 into 1 minus cos omega t whole divided by t. Right? So this is the answer. So using the differentiation of transform formula, we can solve this type of problems. Clear? Okay. So again, we will meet in the next lecture with a new topic, with a new problems. Right. So thank you all.